In the following example, we're asked to find the area of the region bounded by the following curves: x equals y squared, x equals 1, and y equals 0 in quadrant 1. Here we have the graph of x equals y squared. If we then place in the line x equals 1, that's this line, and we're looking in quadrant 1, so we can also just highlight the x-axis here to show that it's this region up here we're looking for. Now, if we find our points of intersection, we need this point, which is the origin, 0, 0, and then we can use this point, which is the point 1, 1. This point of here, of course, on the x-axis is 1, 0. Once we get our points of intersection, we need our representative rectangle. So we draw a rectangle that's consistent with the top curve and bottom curve being the same throughout the whole entire region. So here's our rectangle. Moving it from left to right, we note that the top remains on the curve, x equals y squared, and the bottom remains on the x-axis. In this particular case, if we move that rectangle away, if we can get it to disappear here, we could also try a dy rectangle. So if we try a dy rectangle, we can notice that as this rectangle moves from bottom to top of the region, the bottom remains on the line x equals 1, and the top remains on the curve x equals y squared. So in this case, we'll solve it with a dy rectangle, since our function is given as x equals a function of y. So the area then with respect to y is the integral. Now we're looking at y, so we want y values from 0 to 1. The right side of the rectangle is the line x equals 1, so 1 minus the left side of the rectangle, which is y squared. dy. Integrating now gives us y minus y cubed over 3 from y equals 0 to 1. Substituting gives us 1 minus 1 over 3 minus 0, which is 2 over 3 units squared. As a good exercise for practice, you should try doing the same problem but putting in the dx rectangle. If you do that, you should end up with the area equal to the integral from 0 to 1. dx means the top is root x minus the bottom, which is 0, with respect to x. And if you go through the steps to solve that, you should arrive at an identical answer.